In this first example, I'll show how to create a very simple double linked list. As before, I start by defining a struct to hold some data. Here that's just an int, but it could be any sort of data, maybe with multiple data fields in each struct. Then I declare two pointers to a struct of the same type, one to the next struct in a list, another to the previous struct. Notice here that I've declared two variables, temp, which is a pointer to struct, and head, which is a struct, not a pointer. It's common practice when manipulating lists to keep track of the first element and the last element in that list. You could do that by defining two pointer variables, a head pointer and a tail pointer, and update those to point to the first and last elements. And if the list is changed by adding new elements to the start or end, then those two variables would be updated accordingly. It's a bit neater to put those two variables into a special header structure. I'll explain the value of a head struct in more detail in a later lesson, but for now, just keep in mind that the head struct is treated specially. It's not treated as an element of the list itself. Here I initialize the head struct by setting both its next pointer and its previous pointers to point to the head struct itself, using address of head. I could set them to null, but it's neater to make it point to something valid, which here is itself. The data field is superfluous because this struct is not a real list element, so I set it to -1 just for clarity. Incidentally, it's worth explaining at this stage why when I declare a pointer to struct, I have to allocate memory for it. But when I declare a simple struct variable like this, I don't have to do that. The reason is that the C compiler knows the exact size and location in memory of a simple struct variable at the time the program is compiled and run, so it allocates sufficient memory for it. But with pointers to structs, new structs can be created and deleted during the execution of the program, and since those can come and go at runtime, the memory needed is not known and can't be allocated in advance. And that's why you have to allocate memory explicitly with pointers to structs, but not with simple struct variables. Now, this for loop creates some structs. It allocates memory and initializes the data field for each of them. Now look how it deals with the pointers. It should be obvious, even at first sight, that this is quite a bit more complicated than the code we used to wire up the elements in a singly linked list. In fact, if this is the first time you've used doubly linked lists, the chances are you'll need to stare at this code and run it, maybe using your debugger, to understand what's going on. I look at this in detail in the next lesson.